get this mic. We good to go. I'll begin with a word of prayer. So, Heavenly Father, we thank you for this day. Thank you again for these students this semester. I just pray you help them to just finish their studying and just do their best, Lord, on their finals this semester, Lord. In your name I pray. Amen. Okay, so I'll just take a couple minutes here to talk about these problems. So problem number one.
Do you want to zoom out a little bit because I cannot get to full screen?
Oh. Fine. There we go. Yeah, that's probably fine. Of course, I will post this in Blackboard, hopefully before too long. But so problem one, first you got to write it as a matrix, and then once you've done that, you calculate the characteristic equation. Do it carefully, otherwise everything else falls apart. But when you do that, you should get eigenvalues 3 and 7 here, and I can look at this A minus 3I matrix and kind of eyeball it and see 1 minus 1 is the eigenvector there. And this one, if I want to make this multiply something on this to give 0, 1 minus 2 works nicely. Of course, you can sort through the equations. That's also fine. But one way or the other, you should get vectors that look like this and this up to some scalar multiplication. Then you put it together. So we have C1 e to the 3t times the first eigenvector plus C2 e to the 7t times the second eigenvector. There you go. That's the vector solution. Of course, if we wrote the scalar solution, they'd look like that. Any questions about this one? A lot of people got this one right. I was happy. Less people got this one right.
Did you say sadly?
Oh, I did say sadly. I don't mean it, though. I mean, I meant to say less. The sadly was applied to this problem, actually. I was just getting ahead of myself. So, I mean, do I want you to? I mean, I'm not teaching differential equations next semester, so I don't need to see any of you back again. I mean, there's nothing in it for me to fail you. Although if I failed all of you, then Dr. Wang would have more fun next semester. Let's see here. But no, Dr. Wang almost he had a head-on collision yesterday with some guy, which he said was on drugs. So it was interesting. Ask Dr. Wang about it. I'm sure it's a fun story. I haven't had a chance to talk to him directly yet, but he's okay. It was like it was like a head-on collision, but it was like 25 miles per hour. So kind of like, if it was, I imagine it hasn't done great things for his car, but he's okay. Anyway, so this one, you gotta be careful. You get eigenvalues 2 plus or minus 3i, and then you might have gotten this correct even though you're wrong. So, depending on how you actually do this algebra here, it can look really, really different. So I erred on the side of you being right. If it looked kind of sort of right, yeah.
Wait, so you choose the first line or the second line? Because this one you're choosing the second line.
You can go either way. It's the same equation.
Is it?
Yeah, it better be. If it's not, there's an error, yeah. Now, many of you lost points because you did not follow the instructions. There's overarching instructions that apply to everything in the whole test. They're stated at the beginning of the test. Remember, the term solve means the general, explicitly real solution to the given problem. That's especially relevant here, as some of you just gave me answers that involve I, and that pretty much means that you don't quite know what you're doing. There's something left for you to think through there. We use the, I don't even have that written down here, but remember we wrote down like e to the I eigenvalue times the complex eigenvector. That gives us a complex solution. We pick off the real and imaginary parts, which is this and that respectively. But there is no I in our actual solution because it's a real solution. There's that one. Any questions? Yeah.
One thing I noticed is that this is similar to one of your problems in your notes, and for me, I had a little bit of trouble getting the first eigenvector because I had an algebra mistake in my solving for unit v.
Yeah.
So, in short, if I've done that correctly and my signs are correct, both those equations should be redundant. They should be the same.
Yeah. I mean, it's possible mine is wrong somehow. I mean, I don't think so, but it's possible. It's kind of hard to. It's not entirely easy to see it in this case, because there's this like pesky 3 that's multiplying everything, kind of clouding my judgment. If I divide these equations by 3, I probably can see it better. But anyway. It would help me see why the equations are redundant. It'd be easier for me to, like, if I divide by 3, the first equation is minus 3 minus I, plus, and then the other one's minus 2. And the second equation, if I divide by 3, I've got 5. 5u plus 3 minus I times v. And you can kind of see where, yeah.
It's probably there. I'm just not seeing it.
It is possible there's a mistake in my solution here. It's possible. But that's what you got? Okay. Let's move on to something that people are much further from the truth on, a lot of people. Problem number 3, I asked you to calculate the matrix exponential. So there are different ways you could do that. The one way you could do it would be just to find the general solution to the problem dr dt equals to AR, and then use the formula, which was that the matrix exponential, I think it was x inverse of 0 times x of t, or vice versa, something like that. So you could use the matrix exponential to build, you could build a matrix exponential from a solution matrix, but that's kind of a pain here, because this has got a repeated eigenvalue of 2, but there's only one eigenvector if you get into it. So if you wanted to find the solution matrix, you actually have to work through generalized eigenvectors to construct the solution here. That's not that easy. The easiest way to do this one is just to notice that a minus 2i is this. So the square is 0, which means I can use the magic formula and get this finite series, which is just that, which gives me matrix exponentials. Just now, like, I think maybe 5 people in here got this correct. Something like that. I don't know. Some people did. We had a homework problem that was like it. But it was 3 by 3, I think. So I made a 2 by 2 version of it to make it easier. And then I also have to solve this initial value problem. In other words, I'm looking for the constant such that that constant vector times the matrix exponential gives me a solution. Because remember, by the appropriate choice of constants here, that gives me a linear combination of the columns of the matrix exponential, which is to say a linear combination of solutions, because each column in the matrix exponential is a solution. So, but on the flip side here, r of 0 is just e to the ta times 0, e to the 0, which is I. So in fact, you can put the c equal to 1, 2, and that does it. So the matrix exponential is actually really nice in terms of initial. If you want to solve an initial value problem, the matrix exponential is really, really nice, because all I do is take matrix exponential times the initial, the initial value vector, and that's the solution. So, I mean, that's really, really nice. But of course, you could sort through that with more complicated calculations and still get the same answer. Problem 4, you guys did pretty bad on this one. That's unfortunate, because this is a fairly standard test question for me. If you look back, you'll find it in one sort or another. The original version of this problem had 5 by 5, and I had a complex matrix over here, a complex vector over here. I'm so glad I got rid of that. This sufficed to separate the haves from the have-nots. And but anyway, I'm not rejoicing in your suffering. I'm just saying you guys need to do work here. The starting point is realizing that v1 and v2 are both eigenvectors with eigenvalue 10, which means that those give me eigensolutions down here, right? But v3, on the other hand, if you subtract to the other side, you get a minus 10i times v3 rather, equals to v1, which means that v1 and v3 are in a chain of generalized eigenvectors. So you apply the magic formula with lambda equals to 10, you get this, right? But if we hit v3 on this, then it kills off this. This turns into a v1, that turns into a v3, so we get e to the 10t v3 plus t v1 is the solution that comes from multiplying matrix exponential by v3. So there you go. That's the general solution that we're looking for here. A lot of you guys had this right, and then something weird. I saw things like, I saw one student had v1 times v3, which is especially abstract, like it's the multiplication of the vectors v1 and v3. This is not, I had another student who was dividing by vectors in this part somehow. I saw there was a lot of diversity here, right? There was a diversity of wrong opinions.
It's like a three-sided box.
Yeah, the three-sided, what
Well, no, seriously, I just left the box open.
Oh, I see. That's why it's not a closed box. I got you. You have a question in the back?
Did I say I have a question?
I don't know. You looked like you had a question.
Oh, no.
You looked questionable. Oh, no. Just really tired. Too much engineering in 1 week. Yeah.
How do you do that so fast?
This?
Yeah.
Well,
I feel like
the thing is, I embrace Taylor's theorem. I know what it means for series, and I use it. So Taylor's theorem says that the first and the second terms in a Taylor series expanded around the center point have the meaning of being the value of the function at the center and the derivative of the function at the center. Those are the coefficients. So once I know that y of 0 is 1 and y prime of 0 is 6, that tells me 1 plus 6x is the start of the series by Taylor's theorem. And then I've got something I don't know, ax squared. But then I plug that into here, and I think, before I write down a bunch of stuff, I think about what's the lowest order equation in here? Well, it's the constant term. What's the constant term from y prime prime? It's just 2a. What's the constant term from here? It's just 1 times whatever the constant term is in y prime is, which, by the way, is 6. And is there a constant term in here? Well, no. Everything's multiplied by x, or, so there's no constant term in there, so that's just a equals minus 3, so yeah. Some of you worked much harder to derive this. Yes, no? Yes, yes. And then there's this problem, which many of you made some progress on, but few of you actually got to the end of it. Oops. Come on, go back.
Finding the pattern part is always the hardest.
Right, that's the last 30% of the credit, something like that here. I mean, I didn't push it too hard. I mean, you could simplify this further. You could say minus 1 to the j, and there's a 6 to the j, and you could start playing games with canceling out the 2 to the j in here with all of the 2 factors down here. I mean, you could further simplify this formula if you wanted to, but I was pretty happy, I mean, relatively happy if I saw that you at least had this recurrence relation somewhere and that your answer actually had x's in it. A lot of you, you kind of get to this point of writing down the answer, and then all of a sudden you forgot what you're doing, and I just see like sums of coefficients, but there's no multiplication by powers of x, right? And just to be on the safe side, I wrote the 1 and the x out separately because I'm not sure that this formula actually makes sense when you put in j equals to 0. We could interpret it to make sense, but just to be on the safe side, because at some point in the future I'll have a really picky student reading this solution, and it's in my best interest to separate these off so that that student won't complain. I'm not sure that student's actually in your class right now, but you guys are a little bit more chill, but that's fine. Anyway, so yes, answer. All right, let me move on here. I'm tired of talking about series solutions at this point. Which of those 2 series problems I just talked about is more likely to be on the final?
6.
What's that? 6? Both of them is a good answer. Then you're not responsible for which one I pick. I mean, it gives me greater joy to grade number 5 because I can grade it faster, right? Either right or wrong on number 5, right? I don't have to give partial credit. I can just say wrong, right, wrong, right, wrong, right. It's much more fun to grade. What's that?
Can we just stop at AN for 6?
No, I want the answer. The point is not to show me that you have memorized some procedure. The point is to actually produce the answer. So, that's nice, but that's not the end of it. Okay, anyway. Where was I? This one, yeah. So you guys still need to work on Laplace transforms. A lot of you are not where you need to be yet on this topic. But I mean, half the class got this right, give or take. Another third of this class was kind of in the hunt. And then the other half, just they're lost. Maybe that's some of you, sorry. But So first step, of course, is to convert to the unit step formulas, then take the Laplace transform of each piece separately. By the way, ut times sine t is just sine t for t greater than 0, right? Because, well, anyway, that would produce like an e to the 0s, which would go away. But anyway, so this, by the theorem, is e to the t plus 2 minus sine of t plus 2. Then I got to use my laws of algebra and laws of trigonometry to bust it out into these three terms. And then that gives us 1 over s minus 1. This gives us the s squared plus 1. This gives us the s over s squared plus 1, all times e to the minus 2s. But, all right, so there's that one. The other one down here, I think about a third of the class got this exactly right, something like that. I mean, so there are people who have spent the time to be good at this, but there's other of you who are still kind of working out your demons here. Some of those demons are algebra, and you guys are, I think, getting better, but you know, maybe you're still not quite there. Anyway, this is s squared minus 9 times s squared plus 9, which factors like so. If you factored it wrong at the start, everything else just falls apart. So that's kind of important. And there's probably about 5 of you who factored this wrong. Maybe 4, something like, I don't know, a few. Anyway, so you work through the algebra. After you get through it, you get 0 for A, minus 4 for B, and what else was there? C was 2, D was 2. So the partial fractions gives me this, and then I can do the inverse transformation from that. Pretty straightforward. What's that?
These two are the nicer problems.
Oh yeah, they were nice. I feel like a lot of people were kind of frightened by the earlier problems and they just kind of ran out of time when they got to these.
Interesting. Oh, as you can see from my battery bar, I better get on with it. Let me dim my screen up here in the interest. You see my battery bar. We could go dark at any point. See here. Now this one here, this is a difficult problem, but you guys should be able to do this one, especially if I, say I think, well, from all the Laplace transform questions, which one question could I ask to see if they understood everything? This problem, or something like it, right? Because you actually have to take the Laplace transform. You get 2 pieces. One piece got exponential, one piece does not. The piece without does not need the exponential stuff. It's just going to give us sines and cosines times e to the minus 3t, I think. This piece, on the other hand, I got to do partial fractions on. Otherwise, I can't take the inverse transform of f of s. Partial fractions here looks like that, and it ends up giving you 13ths. I think about 5 of you kind of had something like that. And so this is the first piece. Partial fractions gives me that. And then the theorem says, if I'm taking the inverse transform of f of s times e to the minus s, well, I take the inverse transform of that, and then I evaluate it at t minus 1. So the inverse transform of this is 1. This gives me e to the minus 3t cosine 2t, and e to the minus 3t over 2 sine 3t from that 3 over stuff term. But I got to replace the t with t minus 1 as I do, and then I multiply it by the unit step function.
So to get rid of I noticed that we had the y times that, I think it was like the x squared plus 6s plus 13. We got rid of the s and the 9 by turning those into sines and cosines, I think.
What had happened to the s plus 9?
Oh, yeah.
That's s plus 3 plus 6, which is all I need in order to take. Oh yeah, if you're doing partial fractions on that, you haven't thought enough about how to be lazy. Yes, it's already partial fractioned. You just need to see how to rearrange the numerator. Uh-oh.
I forgot the coefficient.
Forgot the coefficient. Ah.
The 6 and the 13.
Anyway, many of you need to work on this problem. Not necessarily this problem per se, but problems like this problem, right? So a good thing to do would be say, I don't know, if you're having trouble with this one, pick on something a little bit simpler. I mean, do something like y prime prime plus 9y equals to u of t minus 3 or something. See if you can solve that with a friend who knows what they're doing. Find a friend who knows what they're doing. See here. Anyway, I do have other problems like that on old tests if you look back, right? or in the homework. Okay, so here the issue is this is analytic everywhere. I mean, so if you think about dividing this by x squared minus 4x plus 5, the only place where we have a departure from analyticity of the coefficients of y prime and y would be when this thing is 0. When is this thing 0? Well, completing the square shows me that that's only going to be 0 at 2 plus or minus I. My singularities, both complex, and there they are. Now, I asked what's the open interval of convergence for this solution. This solution is by construction centered at 4. So the question is, how far is it from the singularities to 4? So I have to think about that distance in the complex plane. And so I'm going over 2 and up 1. That's the distance of root 5. And so I get 4 plus or minus root 5. That's my open IOC. About 3 people got this right, which is, I'm not happy with that. I think like most people in here can get that right. Yeah? Many people got this more or less right. You know, when I ask questions, you need to answer them. I said, if no motion is possible, then explain why. When I say explain why, I mean explain why. I don't necessarily mean that you have to write a paragraph or something, but this is all I was looking for, really. E1 is less than u of x for each x, right? So no motion's possible. A better answer would have been, you know, no motion's possible because if there was motion, it would give negative kinetic energy, which is impossible, right? But I didn't even fuss if you didn't say that, right? So no motion possible for E1, and then we just have to trace the energy levels. Like here, that gives me this loop. This gives me this. The green doesn't quite close in this graph. It gives me that. The red doesn't quite close. It gives me that. The blue doesn't quite close, but you can see it would. I mean, well, it depends on what happens past where we don't know what happens over here, right? And then over here, I get these. You know, there's no energy level which goes all the way from here over to here. If you have some curve that goes like that, I can tell you're wrong, which made my grading easier. That was not actually my intention, but it just so happens this was really easy to grade. I really like this one. Sorry. But of course, you know, to be fair, maybe on the final, if I was asked this question, maybe I'd do something that had at least some energy levels, which the energy was larger than the potential energy for the whole time. If that happened for the whole range of x, if that happens, then you can have an energy level which goes all the way from one side to the other. You know. But a lot of you were in the ballpark for this, and some people had almost exactly what I have here. So I think you guys, as a class, did better on this than previous classes have. So it's good overall. So you guys have any questions about this particular exam? We'd like to go back and talk about test 1. Do we have a few minutes? What's that? 5 minutes? Yeah.
No, well, I mean, probably about the final. I mean, just like figure. I mean, we're kind of another thing that I feel like might be weighing on a lot of us is terms of length.
So
this test was, I mean, it felt to us like a very long test, which might have been because we were.
It's a little bit long, yeah.
I feel like that was the big reason why a lot of people would mess up things like that solve the equation using the Laplace transform technique.
Yeah, it's possible, but it's also possible they just don't understand it. And it's hard for me to tell the difference. So yeah, I mean, the final exam probably be about as long as one of your tests. So there's probably be a little bit less time pressure on the final. What's that? Oh yeah, I'm in the wrong folder. This does not.
Should we be expecting anything outside of?
Any questions from advanced calculus on your final? No, probably not.
No. Outside of test 1, test 2, and the 2 missions.
What would you like me to ask? I mean, what do you want me to ask you?
What's on the final?
Pretty much. I mean, we're just kind of trying to figure out if there's anything like
you said, if there's a PDE, what would you do with it?
Well, how about solving the boundary value problem? Like basically working through one of the propositions in my notes, but for specific numbers.
So kind of like coming up with your own blank template solution.
Boundary problems.
Yeah, or I think problems, if you look at it, really problems 1, 3, or 4 in the PDE project are reasonable final questions.
One question?
Yeah. They didn't actually require integration is the thing.
With a lot of writing.
Depends on what I ask, but yeah. It doesn't seem fun to grade, though. It's true. You can always bank on my laziness. Let's see here. Well, maybe that's not true. So every once in a while, I get a moment of, I get a moment of inspiration where I think I can bear it. I'll grade that question. Yeah.
What do you say would be the percentage between test 1 and test 2 and 5?
I wouldn't say that because every time I say that, I regret it. I'm not going to forecast percentages. It's a comprehensive final, so what happens, happens. Yeah.
Do you think we'll see something like mass spring or?
Mass spring is unlikely because I didn't actually ask mass spring on a test this semester. Man, I didn't ask mass spring on a test this semester. Ah. Yeah. It was on a mission that I graded.
Yeah, mission 2, number 9,
So I should bring it back.
No.
Oh. Oh, I shouldn't ask mission questions that aren't on a test? So I'll put it on the final. That makes it fair. No? It's not necessary? We're having a discussion about the philosophy of education, whether you should cover things that aren't tested or not. Yes.
Just one thing that I want to ask you though is that I know that there were things that we knew that we were not going to do over test 2 because, I mean, for instance, like the Convergence method or those advanced extreme math problems because they simply be very, very time consuming to do on a test. Can we safely assume that anything that was on these tests is absolutely fair game and the concepts they cover is fair game?
Mm-hmm.
But anything beyond that?
I don't think that's quite accurate, though, because I just said that the 3 problems in the PDE project that did not involve tedious integration aspects of them are certainly really relevant. And, there are things that you're supposed to learn in the homework that I might test on the final that haven't appeared on tests. It's possible. But I think that making sure that I have, if I was a student, I would start by making sure that I had a rock-solid understanding of the problems on the test, yeah. If you do that, then you probably can answer those other questions anyway. Possibly. The Frobenius method is not on the final. That's right. Yeah, that question I will answer. Yes. But that's not entirely truthful because I might test Cauchy-Euler, which is, of course, the most trivial. The Cauchy-Euler is, of course, the most trivial case of Frobenius method, so, But on the other hand, the Cauchy-Euler is also in test 1, so, right? But let's see here. Let's take a whirlwind down memory lane here. Problem 1, separation of variables. Problem 2, and guys, you got to be more careful about details on your solutions. Like so many people, I had X's in the answers, but T, right? Some people I had like a T here and an X over here. I've seen X here and T there. I mean, like you gotta.
I immediately wrote on every single question, assume T is equal to X on every single question.
I'm gonna write at the start of the final. I will write. You are not allowed to write T equals to X.
No, I hate it. I hate it.
Let's see here.
Assume theta is equal to X. I like everything every time. No matter what, I'll turn it into X.
I will work against that. Let's see here.
Pac-Man, I'll turn it into anything.
I say you may turn theta into X at a cost of 10% credit. So you're no. It's just so much trouble to think in a different variable. Anyway, so okay, so these 2 problems are, they're pretty straight down the middle, I think. But you should review our discussion of the interplay between vector fields and level curves and how that all works, right? I mean, the kind of funny thing is, if I solve m dx plus n dy equals to, you better zoom to that, you better, on. If we solve this, and you have a solution to that, geometrically, what does Mn look like? Right, Mn actually looks like this, or possibly on the other side. I mean, but this is the Mn vector field, so, right? If I wanted to find solutions that lined up with the vector, or at least were in the same direction, maybe not either parallel or antiparallel, if I want to find a set of curves that goes like this, right, orthogonal trajectories, then I would actually want to look at something like n dx minus m dy. So that, if I solve this equation, that would be, that would give me level curves that lined up with the arrows, actually. So anyway, are we, is it, it's 12:30. I mean, I'm like a minute, I'm a minute over. I'm not, they can chill. Probably got a test in here today, right? It's Calc 3. It's the final day. It's got to be a test, right? Yeah. Bernoulli, you've probably forgotten how to do this. But you notice I was friendly. I told you which substitution you had to make. You just had to make it. Then we had this. I love this. I really love this way. Well, yeah, but the thing is, you guys stunk up this question. Like, this was not good. And this is the thing that, well, first of all, I'm allowing you a page of notes for the final. So if you get this wrong with a page of notes, shame on you. Let's see here. I mean, because you can actually write down different annihilators, different cases, a few examples for yourself. Please spend an hour on annihilators in your studying. Try to settle this issue for yourself. Many of you still have a lot of work to do there. And not having that clear in your mind makes problems like, this one really, really hard because, if you don't know that your particular solution is supposed to have TE to the T here, well, you're kind of up a creek, right? I mean, you don't know where to go. If you don't have the right particular solution, you're kind of stuck there. And, if you say, well, I'm going to use method, if I'm going to use various parameters, but I can't do the integral, and you say that when there's a perfectly decent solution method where you don't need to integrate and you can solve it, then I'm not very accommodating to you not doing integrals, Other ones, of course, integral solutions fine. Method of superposition is important. Don't forget about the finding velocity as a function of position problems. Those are easy if you remember. Acceleration is v dv dx. Let's see here. Here's that Cauchy-Euler problem I was talking about, which also is my integral solution problem. I don't think many people got this right. This one's kind of challenging, I think, but if you actually take a look back at it and think about everything, you'll find it's actually not that hard. Oh, and that was it. So anyway, let's let those Calculus 3 students come in here and have some fun. I would like it to be an ordinary size sheet of paper. Yes, not legal sized.